See the properties of linear inequalities. Now, in the properties of linear inequality, just like how we have properties on equality condition. When I say equality, something like if x is equal to 3, then x plus 2 is equal to 3 plus 2. You know, these kind of properties. Similar properties are there for linear inequalities also. We look into the first one. See, rather than directly going for the property itself, let's start with a simple example. All right. See, we know that 3 is less than 7, right? Let's take that 3 is nothing but x and 7 is nothing but y. Simple example. Now we'll add 2 on both the sides. So if you add 2, 3 plus 2 is still less than 7 plus 2, correct? So what we can generalize is that if we have x value and it is less than y, then if you add some number a on both the sides, the linear inequality remains the same. So x plus a is lesser than y plus a. Okay, but remember, for this to be true, the given condition is what? X should be lesser than y. So what we write is if, very big condition, if x is less than y, then x plus a is less than y plus a for all a belonging to set of real numbers. Any real number you add, it's always going to be the same. So the point is the linear inequality, this remains unchanged. It's not going to change. First property. Alright, so you can say this is the first property. Second property is pretty much the same thing, but instead of a plus, we have a minus. That means if x is less than y, same thing. So let's take 3 and 7 itself. So when you take 3 and 7, 3 less than 7, say we subtract 2. That's 3 minus 2 less than 7 minus 2. See, 1 is less than 5, obviously. So what can we say now? The property becomes if x is less than y, then x minus a is less than y minus a for all a belonging to R. Again, the key point of this property is not about subtracting. It's about the inequality. Keep this in mind. Alright, so it's never about minus a plus a whatsoever. It's always about this inequality what we have. This remains unchanged. Fair enough? So we added, we subtracted. Now we'll go for multiplication and division. When it comes to multiplication, see, suppose say you have x is less than y, the same logic. What in multiplication or division, what we say is, suppose if you take a into x, it will still be lesser than a into y. A into y. Alright, a into y. Of course, there's a condition, provided a is greater than 0. Greater than 0, not greater than or equal to, because when it's equal to 0, then x is equal to y. That's why. So a is greater than 0. Alright, divided by condition. Same thing. When you have x is less than y, x divided by a. Divided by a. This will still be lesser than y divided by a. And the condition is what? A is greater than 0. Of course, a cannot be equal to 0. Greater than 0. So, the condition is what? Whenever you are multiplying or dividing by a positive number, let's be very specific, positive number. That means the condition holds good. Only then the condition holds good. That is, ax is lesser than ay or x by a is lesser than y by a. Let's take an example. Suppose if you take 4 is less than 9, say we multiply by 3. 4 into 3 is still lesser than 9 into 3. Quite obvious, right? Or 4 divided by 3 is lesser than 9 divided by 3. Obviously, 4 by 3 is 1.33 and this is lesser than 3. Obvious. So, these are the next two properties of inequalities. Next, what if we multiply or divide by a negative number? Alright, if you divide or multiply by a negative number, then the inequality will reverse. Because till now, the whole point of adding, multiplying, whatever, we were always concentrating on this, correct? Or on this one. But now what we have, what if you have a negative number? Let's look into that. If x is less than y, alright, you multiply or divide by a negative number. Alright, suppose say, let's take an example. Say we'll take 4 is less than 6. Okay. Now say I multiply by minus 1. Simple number. So minus 4 is greater than minus 6. Because if you look at the number line, this is 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Correct? This is minus 4. Minus 4. So minus 6 comes somewhere over here. Correct? On the other side. Minus 4 is closer to 0 compared to that of minus 6. So obviously minus 4 is greater. So when you multiply or divide by a negative number, the inequality will reverse. In the sense, we can say if x is greater than y, then ax is greater than ay, or x by a is greater than y by a, provided a is less than 0. Fair enough? This is the condition, a very important condition I would say. Because given condition is x less than y, what you are getting is the inequality has reversed. Alright? There is one more condition where the inequality will reverse. Okay, that condition is the reciprocal. Suppose if you take simple number, okay, say we have x is less than y is the next condition. Alright, say simple number will take, say 1 is less than 4. Very simple. Reciprocate. That is 1 by 1, 1 by 4. 1 by 1 is 1. 1 and 1 by 4. 1 is greater than 1 by 4. See, the initial condition is this. The final condition is this. So what we can tell, if you reciprocate the inequality or that relation between the two numbers, so 1 by x will be greater than 1 by y, provided x and y are not equal to 0. Because you can't do 1 by 0, right? That's why. So 1 by x is greater than 1 by y. Fine? So to sum up whatever we have learnt in this particular video. Now, when does the inequality do not change? Under 4 cases. That is, inequality will not change if you have, that is, x greater than y. The same inequality will be there when you do x plus or minus a and y plus or minus a, correct? One case. Or a into x will still be a into y, or x by a is same thing as this. So provided here a belongs to set of real numbers, correct? But in these two cases, a should be a positive number. 4 cases where you have the same inequality. 3 cases where the inequality will reverse, isn't it? So the 3 cases, that is if x is greater than y, then ax is less than ay, x by a is less than y by a, provided a is less than 0, 1, or when you reciprocate, 1 by x is going to be lesser than 1 by y, provided x and y is not equal to 0. Clear? So this is what we have as the entire properties of linear inequality.